This video is on the objective: find the sample size required to estimate a population mean with a given confidence level. And this is number 2, right? So this is the second video on a question related to this objective from your Newton Alta homework. So again, if you're unfamiliar with the objective, the material, please click on More Instruction, read their what material they have for you, watch videos, look at their examples, and hopefully that'll help you out. But I'm just going to go into it. Okay, so, and I've already done one before, so this is similar. Right. Suppose the number of dollars spent per week on groceries is normally distributed. If the population standard deviation is 7, right, so that's our sigma, $7, what minimum sample size is needed to be 90% confident that the sample mean is within $3 of the true population mean? So again, I'll draw a little picture here for you. All right, so we have this population, and it's the number, and let's say this variable x represents the number of dollars spent per week on groceries. Right, number of dollars spent per week on groceries. And they're telling us that this particular variable is normally distributed with some population mean mu and some standard deviation sigma, where I don't know what mu is. We're trying to guess what mu is, and that's what creating a confidence interval does, right? It helps. It's a guess as to what some sort of population parameter is, whether it be a population mean like this or a population proportion. And we have a standard deviation of $7, right? This was given. So this is known. Now, in order to help us, guess what mu is, we would take a sample from the population, right? Some sample of size n. I don't know what n is here. We're trying to figure out what n needs to be. And the sample mean is, right, x bar, right? The sample, the average number of dollars spent per week on groceries. Right, that's what x bar represents, the average dollars spent per week on groceries for n people, for groups of n people. Now, by the central limit theorem, right, remember the central limit theorem, the distribution of these x bars, if I took all possible samples of size n and looked at all their means, all the x bars, the distribution of those x bars would be normal, or approximately normal, with a mean, mu sub x bar, and a standard deviation of sigma x bar, where the mean of the means, right, the mean of these sample means, the mu x bar, is the mean of the population. But again, this is unknown. So what we use is our sample mean, right, as a point estimate. Our first guess, like our initial guess as to what mu is. So we use x bar as our middle. And the standard deviation is, the standard deviation of the population divided by the square root of the sample size. And then I would draw a little picture here. Here's, a number line with possible values of x bar. It's normally distributed, right? So a nice little bell shape, symmetrical bell shape. Underneath the peak of it on the number line is our mean, our population mean, but again, that's unknown. So we use our sample mean x bar as our initial guess, right? We put our sample mean here in the middle. And then what we're looking for All right, we were told we were trying to create a 90% confidence. We have a confidence level of 90%. 90% confidence. So what we're looking for when we're creating a 90% confidence interval is, some value above the mean. So x bar plus, some margin of error, right? I'll usually label that ME. And then that same distance below the mean, some value below the mean, that's x bar minus this margin of error. I'm trying to find what these values are so that the area under the curve between them is 90%. Right? Now, if the area below between them is 90%, that means the area left over is 10%, and that was that alpha. You might see this symbol showing up in some of these exercises, some of your reading. Alpha is just the area left over. It's called the significance level. Like I said, in other videos I said this, but we don't have to worry about the name significance level yet until chapter 9. But alpha is just the area left over. So you got 90% between, meaning there's 10% or 0.1 left over. And then to find these values, right, this upper limit and this lower limit for these confidence intervals, right, the upper limit would be at x bar plus margin of error. The lower limit would be at x bar minus the margin of error. To find this margin of error, I need to find, how many standard deviations above and below the mean are we, right? So that's where a z-score comes in, and there's an abbreviation for this. If there's 90% between these two, it means there's 10% left over, meaning there's 5% up here, or 0.05, and 5% over here, right, below the lower limit. So to find this margin of error, I'm going to say, how many standard deviations, how many of these am I above and below the mean? And that's where a z-score comes in. So I find the z-score that has 5% above it, right, 0.05. And that's what this little thing, I've mentioned this before in my previous video on this objective. You see a z with a little number below it. That means what's the z-score with with that area above it, with that area to the right. And I'm that many standard deviations, right? So that number times the standard deviation, which would be this sigma over the square root of n. So there's a calculation for the margin of error, how far above the middle and how far below the middle I would need to go to create this 90% confidence interval. But then we take this and solve for n. Solve for n. So that would mean n equals, I would multiply by the square root of n, divide by the margin of error. We'd have the z-score times the sigma divided by the margin of error, but then, to get rid of the square root around the n, we square both sides. And then, of course, n is a sample size, a number of people. You're going to bump this up, round this up to the next highest integer. So bump it up. All right. So let's get into this now. In the problem, right, they said, what is the sample size needed? What minimum sample size is needed to be 90% confident, right, my confidence level, that the sample mean is within $3 of the true mean. Right? So that's my margin of error I want, within $3 of the true mean. So we require a margin of error of 3, right? So the margin of error we require is $3. We know sigma from earlier, that was $7, and then this z.05, this z, the z-score of the upper value that has 5% above it. You can find that from this little table they give us here. Little table of critical values, right? These are called critical values, these z-scores, these numbers that tell us how many standard deviations away from the mean we are. z.05 is 1.645. So back on my picture, that means if I go from the mean. If I do 1.645 standard deviations above and 1.645 standard deviations below, then the area beneath the curve is 90%. So 1.645. I'm going to pop all these in. So the sample size I would need to take to ensure that we have a margin of error, of 3 or less is this. 1.645 times 7 divided by my margin of error is 3, and then we're squaring all this. Pull it up on a calculator. 1.645 times 3, times 7, then divided by 3, and we'll square this value. So 15 people. Right, approximately, it's 14.73, right? Bump that up to 15. So we'd have to take a sample of size 15 or greater to ensure that our guess, our 90% confidence interval of mu, is within $3 of the actual average. No more than 3 more, no more than 3 less. So back here, so yeah, I need to have a sample of size 15 grocery totals to be able to have a guarantee that my guess, my interval, my sample mean is within $3 of the true population mean. And again, they go through it. Please again read through the answer explanations when you get them right, especially when you get them wrong, right? Just to see if you can figure out where you went wrong. Okay, and that's in there. There's no second part to that problem, so that's it. Hopefully that helps, and thank you very much for watching.